Okay, we're going to walk through I guess it's the fourth side of the notes about the ambiguous case for the law of signs. And in this practice set, we're going to try to determine the number of triangles. So we know that if we have the ambiguous case, so we have side, side, angle, we can have the possibility of no triangle, one triangle, or two triangles. So in these problems, our goal is to figure out how many triangles we will have. We do not need to solve the triangle completely. So in the first example, we're told that the measure of angle A is 99 degrees, and then we're given the length of sides C and A. I'm going to make a sketch of this triangle, or possible triangle. So this is angle A, it's 99 degrees. And then I'll label the other vertices B and C. Side length C is opposite angle C, so that's 20 yards. And side A is opposite angle A, so that's 12 yards. And now I am going to start using the law of signs and see what happens and how far we need to go in order to determine how many triangles we have. So we're going to set this up. I know I'm going to begin by trying to find angle C. I know I need to find angle C because I know little c. I know the side length opposite that. So I'm going to say sine of C is sine of C over 20 is equal to sine of A, which is 99 degrees over 12. And if you enter that in your, first we multiply both sides by 20. So we'll get sine C is equal to 20 sine 99 degrees over 12. And if you enter that into your calculator, you get 1.646. And we know that sine is always between -1 and 1, sine of any angle. So we know that this is not a triangle. So this is not a triangle. If you enter this in your calculator, if you say C is equal to sine inverse of 1.646, you'll get, let's see exactly what the calculator says. I'll try that. Trig sine inverse 1.646. The calculator actually tells you that it's undefined. Okay, but you should be able to stop as soon as you see that sine of an angle is less than -1 or greater than 1. Then we'll know that the triangle is not possible. Okay, let's try the next one. So we're told that measure of angle A is 88. So we'll sketch that. So, and don't worry exactly what your triangles look like. A is 88 degrees, and then we know the opposite side length, little a, is 14 miles, and then I'll label my other vertices, B and C, and then little c is 9 miles, so I'll put that on my triangle. We'll begin by setting up the law of signs. So I'm going to say sine of C, capital C, over 9 is equal to sine of 88 over 14. I'll multiply both sides of the equation by 14, and I'll get that sine of capital C is equal to 9 sine 88 over 14. And if I enter that into my calculator, I get that sine C is equal to 0.6425. And I encourage you to pause the video and do the calculations on your own. C is equal to sine inverse of 0.6425. And if you punch that in your calculator, you'll get that C is equal to 40 degrees. Or we know that's the acute angle, that's a possibility. We also need to check the obtuse angle, which would be 180 degrees minus 40 degrees, which will be 140 degrees. If we have that possibility for angle C, let's see if we can actually form a triangle. So we're going to figure out what angle B would be. So the measure of angle B, if C is 40 degrees, we probably don't need to check this, but I will. It's going to be 180 degrees minus 88 degrees minus 40 degrees. And if we enter that in our calculator, we get 52 degrees. And the possibility that we really need to check with the obtuse angle for C would be that measure of angle B is going to be 180 degrees minus 140 degrees, which is the measure of angle C, minus the measure of A, which is 88 degrees. And if you enter that in your calculator, we'll see that we actually get a negative value, right? So if we do 180 minus 140 minus 88, we actually get negative 48. This would be negative 48, which is not possible. So we can conclude that we're just going to have one triangle for this case. We will not have two triangles. The other way you can check is you can also see if 140 degrees plus 88, if that's greater than 180, then you know you don't have a second triangle. That's possible. In the next example, we're given that the measure of angle C is 114 degrees. Since this is an obtuse triangle, we know we have at most one triangle. And, I forgot to mention in the first problem as well, when we had the measure of angle A is 99 degrees, we also know here that we have at most one triangle. So either we don't have a triangle or we have one triangle, and the reason is we already have an obtuse angle. So when we solve for angle C in the first example, we won't be able to use the obtuse angle as a possibility because a triangle can only have one obtuse angle. So let's see though, now in this example, we have to see if we can actually make a triangle. So I'm going to go ahead and make a quick sketch. So C is 114 degrees. Side length C is 42 feet. I'll put on my other two vertices, A and B, and we're told that the length of side B is 27 feet. So let's put that on our triangle. And now we will set up the law of sines to see if this is even possible to have a triangle. So I'm going to have that sine of B over 27 is equal to sine of C, which is 114 degrees, over 42. Multiply both sides of the equation by 27. So sine B equals 27 sine 114 over 42. And if you enter that in your calculator, the 27 sine 114 over 42, we get 0.587. And at this point, we know that we have one triangle. It's not going to be no triangles, because if it were no triangles, sine of B would be greater than 1 or less than negative 1. So if we want to, we can double check. Sine inverse of 0.587 is going to give us 36.0 degrees. So we can conclude that we have one triangle in this case. So we can actually form a triangle, but we can't form two triangles because we already had an obtuse angle, which was angle C. All right, the next one. We're given an acute angle. So we could possibly have two triangles here. So we'll have to check for that. So I'm going to sketch a triangle. So we know that angle B we're given is 41 degrees. Side length B is 27 centimeters. I'll label my other two vertices, A and C. And we're given that side length A is 33 centimeters. So we'll begin by trying to find angle A because we know side length A. So let's go ahead and set up the law of sines. So we're going to have sine of A over 33 centimeters is equal to sine of B, which is 41 degrees, over 27 centimeters. We'll multiply both sides of the equation by 33. So sine of AA equals 33 sine 41 degrees over 27. And if you enter 33 sine 41 over 27 in your calculator, you get 0.8018. So we know that we can indeed form a triangle. And now let's figure out what A is. A is going to be sine inverse of 0.8018. And when you do this, just drag that value down from the previous calculation. When you do sine inverse, there's no reason to enter the decimal approximation. We get 53.3 degrees, or we can get the obtuse angle, the supplement of it. So 180 minus 53.3 degrees, which is equal to 126.7. So now let's check two cases. So we could have that A, the measure of angle A, is equal to 53.3 degrees, or the measure of angle A is equal to 126.7 degrees. And now we have to see if this obtuse angle that we found actually will still work if we can make a second triangle. That's what we need to do right now. So let's see if we have enough rotation left to form angle C. So the measure of angle C in this case is going to be 180 minus the measure of A, which is 126.7, minus the measure of B, which was 41. And when we enter that in, we get 12.3 degrees. So we can indeed form two triangles. We don't need to do this calculation, but I'll do it. I'll find the measure of angle C in the first case. That would be 180 minus 41 minus 53.3, which would be 85.7 centimeters in this case. So here I kind of ran out of room, but we can form two triangles. So I'll squeeze that in here, two triangles. Let's go on to the next one. So here we're given an acute angle again. So we could have the possibility of 0, 1, or two triangles. So let's see what's going to work in this case. I will make a quick sketch. So I've got angle B is 72 degrees. I'll put A and C, my vertices, on there. Length of side A is 26 inches, and the length of side B is 23 inches. Let's set up the law of sines. We're going to be using angle A since we know the side length opposite it. So we're going to have sine of A over 26 is equal to sine of B, which is 72 degrees, over side length B, which is 23. Multiply both sides of the equation by 26. So we're going to get sine of A is 26 sine 72 degrees over 23. And if you enter that in your calculator, you get 1.075. So since this is greater than 1, we know that no triangle is possible. So this is not a triangle. So we don't have any triangles in this case. And let's do the last one where we're supposed to determine the number of triangles. So I'm going to make a sketch. First note that this is an acute angle that we're given. So we have the possibility, all three possibilities, 0, 1, or no triangles. So I'm going to make a sketch just to help me visualize it. Measure of angle B is 63 degrees. Side length B is 23 miles. We're given that side length A, so I'll put my vertices on, is 25 miles. So we are going to be finding the measure of angle A first because we know side length A. So we're going to set this up as sine of A over its opposite side, 25, is equal to sine of B. So sine of 63 over 23, multiplying both sides of the equation by 25, we get sine of A equals 25 sine 63 over 23. Entering that into our calculator is 0.968. So that's a valid number for sine of an angle. So we will have at least one triangle. So A is equal to sine inverse of 0.968. That turns out to be 75.6 degrees, or the supplement would be 180 minus 75.6 degrees. That turns out to be 104.4 degrees. And now we have to see what the measure of angle C would be for each of these two values for angle A. So if we have a measure of angle A is 75.6 degrees, or the measure of angle A is 144.4 degrees. Let's see what the measure of angle C would be. So C, the measure of angle C in this case would be 180 minus B, 63 degrees minus 75.6. So we know the acute angle should work. This is 41.4 degrees. We really technically didn't need to do that. But I'll do it anyways. The measure of angle C, this is the one we really need to check, is going to be 180 degrees minus the measure of angle A that we found, 144.4 degrees, 104.4 degrees, sorry, minus the measure of angle C is 63 degrees. And when we do that, we get 12.6 degrees. So we can therefore conclude that there are two triangles in this case. All right, the next two examples we're going to see, sometimes we can tell if we have a triangle or if how many triangles we have just by looking at the information without diving into the law of sine. So let's look at this first example. We're given triangle, a triangle ABC, and we're told that the measure of angle C is 10 degrees. And the question actually says, in the following example, I know for a fact that a maximum of one triangle can be formed just by looking. And the reason we know that there's a maximum of one triangle, we could have no triangle. But since the measure of angle C is obtuse, we know that we will have at most one triangle. At most one triangle, because when we do the law of sines, the measure of angle B, which would be the one we'd be finding first, must be acute, and that's because the measure of angle C is already obtuse. So there is no need to check for the second possible triangle with the obtuse angle for B, which would be 180 degrees minus the acute angle for B, right? There's no reason to check for the supplement because we already have an obtuse triangle. Let's take a look at the next page. Then it says, in the following example, I know for a fact that no triangles can be formed with the information given. How do I know? What would happen if I actually tried to solve this triangle? So I'm going to sketch this triangle to begin with. So in this case, we're given an obtuse angle, which is 146 degrees. So like the previous problem, we know there's either at most one triangle, maybe zero triangles. And how do we know that in this one, we don't even have a triangle, that this information doesn't represent a triangle? So I'm going to label the information. So side A is 14 centimeters. I'll put on my other vertices, B and C. And side length C is 25 centimeters. So when we look at this triangle, we notice that side length C is greater than side length A. But remember from the triangle inequality theorem, I'm going to write that down. The triangle inequality theorem says that the side opposite the largest angle must be the longest side. Okay, so I'll write that down. It says that the side opposite the largest angle must be the longest side. Or conversely, you could say the side opposite the smallest angle is the shortest side. But in this case, we know that angle A is the largest angle. So this is obtuse, so it's the largest angle, but 14 is less than 25. So we know that this is not a triangle. So I'm going to write that down. Angle A is obtuse, so it is the largest angle, which means that A must be the longest side. So C cannot be longer than A, which is the case that we have. So we'll conclude in this case that this is not a triangle because it violates the triangle inequality theorem. Okay, on the next page and a half or so, we are going to actually practice solving triangles using the law of sines. These are all cases of the ambiguous case where we have side-side angle. That will be the information that we are given. Okay, so we're going to walk through these step by step. And in each case, we need to know we may have 0 triangles, 1 triangle, or 2 triangles. Okay, so I'm going to go ahead and sketch triangle. So I've got triangle A, B, C. Measure of angle A is 52 degrees. Side length C is 32 centimeters. Side length A is 27 centimeters. And now we'll begin. Notice that we do have side angle, right? So we're going to be careful when we're using the law of sines here. Okay, so we'll start. Sine of C over side length C, which is 32, is equal to sine of 52 degrees, that's angle A, over 27, side length A. Multiply both sides of the equation by 32. So sine of C is equal to 32 sine 52 degrees over 27. If we enter that in the calculator, and please do that on your own, you get 0.9339. So C is going to be sine inverse. Remember, when we need angles, we're going to use sine inverse of 0.9339. That turns out to be 69.1 degrees. But we also need to check for the second angle. And for that, we need to find the supplement. So that'll be 180 degrees minus 69.1 degrees, which is 110.9 degrees. So these are our two possibilities for angle C. And now we have to see if both of them work. So I'm going to put here, what if C is 69.1 degrees or C is 110.9 degrees? What would we get for our third angle, angle B? So I'm going to determine that. So 180 degrees minus angle A, which is 52 degrees minus 69.1 degrees. That's going to be our first angle, 58.9 degrees. We know that one will work. And now we need to find the second possibility for the measure of angle B. So that'll be 180 degrees minus 110.9 degrees minus 52 degrees. That turns out to be 17.1 degrees. So we actually have two possible triangles in this case. And now we have to go through and find the third side. So little b. So I'm going to put little b in the numerator because I'm looking for side length. So little b over angle B. I have to use my particular angle B. So in this case, that'll be sine 58.9 degrees is equal to, I'm going to use a side length A and angle A because those are the ones that were given. 27 over sine 52 degrees. I don't want to use a rounded value. Multiplying both sides by sine 58.9, we get B is equal to 27 sine 58.9 degrees over sine of 52 degrees. And if you enter that in your calculator, you get 29.3 and centimeters. And then we'll find little b in the second case. So little b over sine. And this time I'm going to use angle 17.1 for b. So sine of 17.1 degrees is equal to 27 over sine of 52 degrees, focusing on angle A and side length A. Again, those were the ones that were given. Multiply both sides of the equation by sine of 17.1. So b is 27 sine 17.1 degrees over sine 52 degrees. Entering that into my calculator, I got 10.1 centimeters. So we have two triangles. I'm going to summarize those two triangles. So we could have C is 69.1 degrees. That's a measure of angle C. A measure of angle B is 58.9 degrees. And side length B is 29.3 centimeters. And the second case, or we could have the measure of angle C is equal to the obtuse angle, which was 110.9 degrees. The measure of angle B turned out to be 17.1 degrees in this case, and side length B turned out to be 10.1 centimeters. They gave us units in this case, so I'll put centimeters. Okay, and that is our conclusion. So that's the most involved case for law of sines, where we actually have two triangles and we need to solve for both. Okay, let's try the next one. So practice B. So in this case, measure of angle R is obtuse, so I'm feeling a little better about this one. I know that we will have at most one triangle, maybe not a triangle, but at most one. So I'm going to go ahead and make a sketch. So R is 109 degrees. I'll put on my other vertices, S and T. We'll put on the side lengths. Little t is 31 feet. Little r is 29 feet. So we'll put those on. We will begin by trying to solve for angle T, since we know side length T. So I'm going to use law of sines, putting sine in the numerator because I want to find an angle. So sine of capital T over its side length T over 31 is equal to sine of R, which is 109 degrees, over side length R, which is 29. Multiplying both sides of the equation by 31, we get sine of T is 31 sine 109 over 29. So T is equal to sine inverse of, actually, you know what? Rather than writing this whole thing out, let's calculate what 31 over sine 31 times sine 109 divided by 29 is. That turns out to be 1.01, and immediately, since sine of t is greater than 1, I know that this is not a triangle. I can conclude that right there. If you go ahead and you do t is sine inverse of 1.01, your calculator will say undefined. In that case, you're going to conclude that this is not a triangle. Okay, flipping to the back side. A couple more examples. Here we're given triangle STR and we're given the measure of angle R, which is acute. So we may have 0, 1, or 2 triangles in this case. So I'm going to go ahead and make a sketch. R, we're told, is 26 degrees. I'll put that on. The length of side length R is 17 inches. I'll put on my other vertices, S and T. And we're told that side length T is 12 inches. So we'll begin by solving for angle T in this case, because we know side length T. We know the side opposite it. So once again, we're going to start using sine in the numerator because we're trying to find an angle. So sine of t over side length t, which is 12, is equal to sine of r, which is 26 degrees, over 17, side length r. Multiply both sides of the equation by 12. So sine of t is 12 sine 26 over 17. If you enter that in your calculator, you get 0.309. So we know that there is at least one triangle in this case because sine of t is between -1 and 1. So that's good. And now let's do sine inverse. So t is sine inverse of 0.309. And once again, copy that value from your calculator into your sine inverse function. So t turns out to be... this is 18.0 degrees, or we need to find the supplement, which is 180 minus 18, which is 162 degrees. So now we need to check both of these cases to see if we can get the second triangle. So for the first triangle, let's make sure that the second triangle works. We'll find the third angle. So the measure of angle S for the acute angle for T would be 180 minus angle R, which is 26 degrees, minus angle T, which is 18 degrees. That turns out to be 136 degrees. And then let's figure out if we actually have a second triangle. So we'll do here, we'd have the measure of angle S is equal to 180 degrees minus angle R, which is 26 degrees, minus 162 degrees, which would be angle T. This turns out to be negative 12. So we can conclude that this second angle is not possible. So we're just going to have one triangle. So let's continue on and solve it. We already know the measure of angle T is 18 degrees. The measure of angle S is 36 degrees. And the only thing left to find is side length S. So we will use law of sines one more time. So S over sine of S, which is 136 degrees, is equal to R, 17 over sine R, which is sine 26. Multiply both sides of the equation by sine 136. So S is equal to 17 sine 136 over sine of 26. Punch that in your calculator, you get 26.9 inches. So to summarize, we have one triangle, we solved it, and we found that the measure of angle T is 18.0 degrees, the measure of angle S is 136 degrees, and side length S is 26.9 inches. All right, in letter D, we're given a triangle, we're given an acute angle, so we could have the possibility of two triangles here, so we'll need to be careful. So I'm going to go ahead and sketch my triangle. So the measure of angle A is 61 degrees, side length A opposite angle A is 16 feet. I'll put on my other two vertices, B and C. Side length C is 20 feet. And so we will begin our analysis by solving for angle C, since we know the opposite side, which is 20 feet. So sine of capital C, or angle C, over 20 is equal to sine of A, sine of 61 over 16. Multiplying both sides of the equation by 20, we get sine of C is equal to 20 times sine 61 over 16. If we enter that in our calculator, we get 1.09. So we know that this is not a triangle, because sine, we should get something between, what's actually going to be probably between 0 and 1, or negative 1 and 1 is technically what we need. But for these triangle problems, we're not going to get negative values. All right, last one. So in this problem, we have, let's check, we're given an acute angle, so we could have the possibility of two triangles. So I'm going to go ahead and make a sketch. So angle K is 31 degrees, side length K is 32 centimeters. Put on my other vertices, H and P, and we're given side length P is 35 centimeters. So we will begin by solving for angle P, because we know the side opposite, which is 35. So let's set up law of sines. So sine of angle P over 35 is equal to sine of 31 degrees, which is angle K, over side length K, which is 32. Multiply both sides by 35. So sine of P is 35 sine 31 over 32. And if we enter that in our calculator, we get 0.5633. And then we take sine inverse of both sides. We know we will get an angle because it's not more than one. So sine inverse of 0.5633 is equal to 34.3 degrees. Or we need to also check the obtuse possibility, which would be 180 degrees minus 34.3 degrees, which is 145.7 degrees. So we have two possibilities for the measure of angle P. I'm going to write them both down here. So the measure of angle P could be 34.3 degrees, or the measure of angle P could be 145.7 degrees. Let's find the third angle in this case, which will be angle H. So the measure of angle H will be 180 degrees. That's how many degrees are in a triangle, minus angle P that we just found, 34.3 degrees, minus angle K, which is 31 degrees. That turns out to be 114.7 degrees. And let's see if the obtuse angle will work, if there's enough rotation left. So we'd have 180 degrees minus angle K, 31 degrees, minus angle P, 145.7 degrees, which is 3.3 degrees. So we actually will have two triangles in this case. So now we need to find the last side, little h, using both of these angles, the 114.7 and the 3.3. So we'll set up law of sines. This time we'll put side lengths in the numerator because we're solving for side lengths. So little h over sine of h for this particular triangle, 114.7, is going to be side length k, 32, over sine of k, which is sine 31. And we'll multiply both sides by sine 114.7. So h is equal to 32 times sine 114.7 degrees over sine of 31. And that turns out to be 56.4 centimeters. And we'll do it one more time for the second triangle. So little h over sine of h, in this case, which is 3.3 over sine 3.3 degrees, is equal to 32, which is k, over sine of k, which is sine of 31 degrees. Multiply both sides of the equation by sine of 3.3. So 32 times sine 3.3 over sine of 31 degrees is h. And if you enter that in, you get h is 3.6 centimeters. And now we can summarize. We have two triangles in this case. And the summary is the measure of angle P for one triangle is 34.3 degrees. The measure of angle H is 114.7 degrees. And H is 56.4 centimeters. And for the second triangle, we have the measure of angle P is 145.7 degrees. The measure of angle H is 3.3 degrees. And the length of side H is 3.6 centimeters.